scattering of light completed or we are yet to? Whose is this?
It was kept here.
Okay, I'll use it to. Where were you? I'm seeing many faces for the first time in a while. What happened then? Okay. Did we finish the last chapter? Scattering of light?
Yes.
Completed?
Yes.
Did we do the questions?
Yes, sir.
Yes.
We did question?
Yes.
Okay. So let's start magnetic effect of current. Questions right? Are any questions remaining? So silence everyone. We are starting a new chapter which is magnetic effects of current. So the first topic is Oersted's experiment. First topic is Oersted's experiment. Before that, I think you're familiar with magnet.
Yes.
All of you are familiar with magnet?
Yes.
So let us quickly revise the properties of magnet. Those who want to sit in the classroom, stay silent. Okay? If I hear the noise again, I'll start sending you out. Okay? I'll start with you. This is a warning now. Okay? Anybody found troubling or making noise in the class, देखो ये सुन के भी बात कर रही हो. हाँ तो चुपचाप पास करना उसको. Why have to speak? How can I teach otherwise? Nothing will go in your head when you're talking. So the first topic is Oersted's experiment. But before that, let us quickly revise the properties of a magnet. So can you tell me two properties of a magnet? Raise your hands. Who would like to answer? So every time it's only you. What about others?
Both pole are equal.
Both?
Pole and sound pole are equal.
Equal?
Still.
Okay.
The magnetic north pole repels another magnet's magnetic north.
Okay, so like poles repel each other. This is the property. Like poles
Repel
repel each other. And unlike poles,
attract
attract each other. What else? So like if you have two magnets, this is not, then they will repel each other, right? And if this was north, and this is south, then it will attract each other. Okay. What are the different types of magnets? Examples of magnets. One is bar magnet.
Then electric magnet.
Bar magnet. Then
Electromagnet.
so electromagnet we will discover. So you have electromagnet. What is the example of electromagnet?
Solenoid.
Yes.
So what about the type of magnet that is formed after putting
You
it?
leave electromagnet. Just tell me natural magnets. One is bar magnet. Horseshoe. What else? So horseshoe is nothing but a bar magnet turned in U shape. Okay? So this is north and south. So this is a horseshoe. What else? Which other magnet type you know? These are all permanent magnets. Bar magnet, horseshoe magnet. This magnet can be changed. This is flexible. And we will learn about it in this chapter. We are yet to study this. Magnetic compass. Magnetic compass. Magnetic compass is also a magnet. So these are all examples of magnet. Magnetic compass, magnetic needle, these are all examples of magnet. Now, in properties, one property is like poles repel, unlike poles attract. Tell me one more property of a magnet. Yes, it attracts small pieces of iron. Okay, it attracts small pieces of iron. So it could be iron powder or iron powder. What else?
The magnetic field lines of a magnet.
Field lines, you leave it right now. What happens when the magnet is suspended in air? What happens when the magnet is suspended in air?
It goes to a particular direction. Like tried it in some passages.
What is the property of magnetic compass?
It points towards the.
It always points in one direction, which is
north.
geographic north, right? Same thing happens to a suspended magnet. If you tie a bar magnet and suspend it like this, so it will settle down in north somewhere. Okay, so it has a directional property.
The geographic north is magnetic south.
Geographic north and magnetic south, yes, correct. Okay?
What does that mean?
Yeah, it means the first point. What he meant is, wait, when the magnet is suspended, it rests in north-south direction. So if you take a magnetic compass, it always rests in north-south direction. So magnetic compass is also a magnet, a very thin bar magnet, okay? And it is pivoted on some axis. So either you suspend a magnet by tying it to a thread, it will settle down in north-south direction, or you can pivot it on some axis. So then again it will point in north direction. So why it points always in north direction? That is what he meant by magnetic south. So there you go. If you have a earth, right? If this is geographic north and this is geographic south of earth, and whenever you keep a compass, let us say here you keep a compass, it always points in north direction. Okay? So if you have a magnetic compass like this, and if it is pointing in, say, this direction, let us first decide this is north, south, and east, west. So whenever you keep a magnetic compass anywhere on the surface of Earth, it will point in north direction.
Sir, but north will repel each other, right?
So it is geographic north, but it is magnetic south. That's what he meant. So Earth can be thought of as a giant bar magnet. Okay. Towards the geographic north is Earth's south pole. Understood? Why the magnetic compass always points towards the north? Because Earth itself is a very big magnet. Okay, and the compass north will point towards opposite pole. So Earth's magnetic south lie in the geographic north. Now you got the answer. What does it mean?
Yes.
Because Earth itself is a very big magnet. Okay. So then there is one more property of the magnetic field of the magnet. Suppose you have a bar magnet, right? So in a region around the bar magnet, any other iron piece, okay, it will experience force of attraction towards the magnet. So why it is so? Because around the magnet there is its region of influence called magnetic field. Okay, so it is due to the magnetic field of the local magnetic field of the bar magnet, this iron piece is getting attracted towards it. Okay, and if you keep a magnetic compass, let us say, for example, if you keep a magnetic compass here, then what will happen to the magnetic compass? If this magnet was not here, hear me out carefully. If this magnet was not here, if you keep the magnetic compass, where will it point? It will point like this, north. Because it will point towards Earth's north pole, right? But the moment I bring the magnet over here, now it will repel the north pole of this magnetic compass, because magnetic compass is also a magnet, right? So this north pole will repel it, so its needle will become like this. It will deflect the magnetic compass. Understood? Because both are magnets. ये इसके नॉर्थ पोल को क्या करेगा? रिपेल करेगा, है ना? ये जो मैग्नेटिक कंपास का ये वाला पॉइंट है वो उसका नॉर्थ पोल है और ये इसका साउथ पोल मैग्नेट है. So now it will be repelled. ठीक है? So when we shift the compass elsewhere, let us say I mark this point and I keep the magnetic compass here, then we see that it points in this direction. And likewise, when we keep shifting the magnetic compass and mark a dot where its north pole points, we get this kind of a line. Okay, this is called magnetic field line. So the magnetic field is the region of influence around the magnet where any other magnet will experience a force of attraction or repulsion. So here north pole is repelled because this was not repelled, but as it comes here, it is south pole. So now the north pole is pointing towards south pole. Okay, and inside the magnetic field line travels like this, south to north. So magnetic field line actually make a closed loop. It emerges out from the north pole and merges into south pole. Understood? This is how it is. How did we draw the magnetic field line? With the help of magnetic compass, following its north pole. Wherever its north pole is pointing, we are marking a dot and shifting the compass there. And then we are marking a dot wherever this north pole of the magnetic compass is pointing. So it is pointing in different directions, and when we join the dots, we get a closed loop. This is how. So when we can keep this compass here. So again we get different dots, and we can join them together. So we get many field lines. Okay. So likewise we can draw field lines. So what is a field line? It is nothing but it represents magnetic field of the magnet, and how the field line is, what is the direction of the field line, that also it gives. So are you getting what I'm trying to say?
So what do you mean direction of field?
At every point the direction is changing. The magnetic compass will always follow the magnetic field line of the magnet. So magnetic field line is forming closed loops. Okay? So whatever, wherever, if you keep any magnet, whatever direction it is oriented, that is the magnetic field line. So it is the region of influence, no? It will influence what? Magnetic substance. So magnetic substance will be aligned. Right? Wherever the force is applied, it will align in that direction. So magnetic field line is nothing but it will align any other magnet in the direction in which it is acting. Is that clear? So the magnetic field is represented through what is called as magnetic field line. And how to draw magnetic field line? With the help of compass. Wherever the magnetic force effect can be felt. So one example is the compass. Is that clear? Okay. So we have to study about what are the properties of magnetic field lines. So that we'll study after discussing Orsted's experiment. This is enough for now. Okay. So what did we discuss? We discussed magnetic field. And magnetic field lines. Of a bar magnet. We just discussed this. So every bar magnet will have a magnetic field around it. And this magnetic field is stronger than the magnetic field of Earth. Right? What is magnetic field of Earth? It is coming out of South Pole, geographic South Pole. This is how the Earth is forming magnetic field. Like this, there are so many magnetic fields. Right? You can also see the properties of magnetic field line. What is the property of magnetic field line? It emerges from the North Pole, see the direction, and enters the South Pole outside the magnet. And inside the magnet, from South Pole to North Pole. So it forms a closed loop, comes out of North Pole, enters from South Pole. This is the first property. Second property is it does not intersect each other. Can you see any two magnetic field are they intersecting each other? No. अगर intersect करेगा तो क्या हो जाएगा देखो. What did I tell you? At any point, the magnetic field is having a unique direction, correct? And that direction is along the tangent. This field curve, what is the direction at any point? Let's say I want you to tell what is the direction of magnetic field is. So while going from north to south, it will be along the tangent. So at every point, the field direction is unique. You see, here it is here. Now, but every point, the direction is unique. Now imagine if the field lines are intersecting at any point. Let us say these two field lines are intersecting. So at this point, what direction will you take at the point of intersection? There are two tangents possible now. This side also, this side also. Okay? So at the intersection, two directions are possible. But that is not allowed. Because magnetic field at any point will have only one direction. Is that clear?
Yes.
Because it is a vector quantity. So it will have a magnitude, meaning its strength. So magnetic field is expressed in Tesla. The same Nikola Tesla, right? So magnetic field is represented as Tesla. That's the unit of magnetic field. And it has a unique direction. So value and direction are unique at any point. At every point the direction changes. And that is represented as tangent on the magnetic field curve. Is that clear? So all these properties are summarized. Properties of magnetic field lines. Right. Then wherever the magnetic field lines are crowded, right? The magnetic field strength is more over there. Right. So it is crowded near the pole. Can you see? And as it goes out of the pole, it is spreading out. So as you go away from the magnet, the magnetic field strength will reduce. Okay? So in your volumes, there you go. So there are two ways of drawing the magnetic field lines experimentally. One is you place the magnet on a table and keep a glass plate on top of it. Okay? Listen here. This is page number 139. How to draw magnetic field lines. In lab, maybe they will ask you to do so. So place the magnet on a table. On top of it, you can keep a glass plate, right? Or you have a chart paper and place the magnet on top of chart paper. Then mark one point near the North Pole and keep the compass, right? Wherever the compass's North Pole is pointing, compass's North Pole is this. Okay, you mark a dot over there, right? Then shift the compass and place the tail of the compass there. Then again mark the dot. You will see that the North Pole of the compass is changing direction. So when you mark all the dots and join the dots, you will actually get these curves. So you can just shift the place a little and you can draw so many lines. So this is one way of drawing the magnetic field lines. So you get it. But how to close the loop? In this situation, you can't close the loop because you can't enter the compass into the magnet. So the other way is you keep a glass plate on top of the bar magnet and then rotate the compass. So then you will see that it makes a full loop. Is that clear? Other thing you can do is, after keeping the glass plate, you spread iron powder. After spreading the iron powder, gently tap the glass plate. So when you do like this, then these iron powders will arrange itself like this. Okay? Let me show you a demonstration on the.
Wouldn't all of the iron filings just get clumped in the magnet itself?
No, because each iron powder piece becomes a magnet itself.
It's that one that it obtains the property.
Yes. The magnetic property is induced. Magnetic field lines. Drawing magnetic field lines. Drawing magnetic field lines of a bar magnet. Just check this. This is smaller, right? Which one should I show? एक बार ये देख लो, फिर next वाला भी देख लो. Is this speaker off?
So the theater volume is less. You just have to increase it from.
With simplified get elected and perfected.
This is the outline of a magnet. Just doing it without a magnet. Or just drawing it. We won't experiment. See this. This is in action. Now this is the magnetic compass. This is how you'll see something resembling this. So it has four directions: north, south, east, and west. So this red is always pointing in the north direction. So now you can turn it and align the north direction. So this is the north direction. Okay. And this is magnet. In magnet, the red portion is always north. So this is pointing to Earth's north, right? And this is magnet's north. These are two different things, right? Now let us see how do we draw the magnetic field line. So just check. So this is what I was saying. So this is the north pole and it is repelling the red north pole of the magnetic compass. This is the pivot on which it is circling or rotating, right? So you mark the dot here. Now it will be shifted. So tail will be placed here now. And then mark the dot where it is pointing again. And you will see that it will keep changing. So this is pointing in this direction. Where the direction is? Over here. This is the direction of the magnetic field. Now see what happens. Tail is aligned. And rightly so, because this is south pole. So the north of the compass has to be attracted here. Got it? So this is how the field line is drawn. And field line is everywhere. So I can start from here, here, anywhere, or here. Okay? Just see. Understood? So is there no magnetic field line here?
There is.
There is. It's everywhere. And it is continuous. So there is no gap, right? So everywhere there is magnetic field line. And this is half diagram. So this is why we needed a glass plate. So if you kept a glass plate over bar magnet, then you would be able to complete the full loop. Here you have to enter inside the magnet. No? You can't take the compass inside. Understood? So this is how it is. And let's see if there is an iron powder experiment. This one. This is a short. Yeah, look here now. So if you spread iron powder, then too you can. There used to be a skip video. There is no more there.
And eventually.
So there are two magnets plotting magnetic field line. This is all. You're keeping a chart paper on top, so you can keep a glass plate also. Now iron powder is being spread on it. See how this iron powder is arranged? Not any tablet. So can you see? This is the magnetic field line. Okay. And then you can keep like it's demonstrating how the field line will be when these magnets are repelling, north, repelling each other. Now you see the magnetic field line will be repelling each other. So you can draw different types of field pattern. You see, here there is no field line, you are repelling. So field line is coming like this. See, so it's coming like this. Okay, that's it for now. So I think this is they are attracting each other, right? तो यहाँ पे दोनों साथ में जाएगा. So we want to see. Okay, see. Now there will be a straight line between them. Earlier there was a gap. Now it is attracting. So you got to gently tap to see the nature of the field. See, it is aligned wherever the field line is. Clear? Now this we are going to study. We have not yet studied. So this is a good. We may revisit later on. Okay. So now let us do the Oersted's experiment. You got a fair idea now how the magnetic field lines feel. This is a completely experimental chapter. No numericals, but lots of laws. Okay. No numerical, but you have to apply the laws to get the direction of field line. Now, what was Oersted's experiment? Oersted experiment says that every current carrying wire has magnetic field around. Every current carrying wire has magnetic field around. Yeah. So let us draw a circuit.
Sir,
Yes.
so what would the magnetic field of a Horst magnet look like?
What would what?
What would the magnetic field of a Horst magnet look like?
It will go from north to south. Like this. Okay. And here it will be like this. Understood?
So that's every. That's every.
What?
That's every.
Every. Every current carrying wire has magnetic field around it. This is the observation of Oersted. So what is the current direction in this case? This is all the current. We have to always say conventional current direction from the positive terminal to negative terminal of the battery. Right. Now what is seen here? If the magnetic compass is kept below the wire, now this is the north direction. Let us say this is north, south, east and west. So before, right now, is there any current flowing when the key is not closed? No current. So when no current is flowing, then the magnetic compass is pointing towards north direction. Where is this compass placed? Below the wire. I mean, there was a compass and this circuit was kept over it. Understood? Understood. Let me draw it like this. What we did is SN. This is a brown conductor or red conductor, right? The magnetic compass is placed below. And when there is no current, the compass was directed like this. It was pointing in the north direction. Now, understand this. So now, when the current is flowing, what is the direction of current? This compass will show some deflection. This is the observed fact. Where does it deflect? It deflects on the right direction.
गर्मी लग रही है।
So compass.
नहीं करनी है
क्या ठंडी है? क्यों जाओ आगे?
हम सबको लग रही है
कौन?
हम सब
क्या लगा बैंक को?
नहीं
क्यों? ठंडी
Yeah, yeah, yeah.
चुपने है थोड़ा आगे तक ही बैठो
नहीं बैठो। अरे
The magnetic compass reflects in the right direction in this situation.
अरे कंप्यूटर आ जाए।
Where is the magnetic compass kept? Below the wire. Then it deflects in the right direction.
Sir, this is your both the fans ACs are also on.
AC से 27 पे रखा है।
So please turn off the fans. We don't require both ACs, both fans so cold.
इसको slow कर दे फैन।
Sir, music work.
नहीं हम सबको लग रही है। इधर की इधर आगे पार्ट्स।
आगे का फैन
ऑफ कर दे। आगे का
जिसको इसको गर्मी लगे बाहर जाओ। अकेला बैठा है क्या क्लास में? एसी चल रहा है ना? क्या बताया मैंने? कंपास किधर डिफ्लेक्ट हो रहा है? कंपास किधर डिफ्लेक्ट हो रहा है?
राइट है।
देखो मुझे बोल बोल रहे कंपास किधर रखा है? तुम बताओ। Where is the compass kept? Below the wire or above the wire? It is kept below the wire, written over here. Kept below the wire. Then it deflects in the right direction. Okay? If the compass was placed above the wire, same situation, current going like this, right? When we place the compass above the wire, then it deflects in the left direction. क्या? और नहीं समझेगा उसको। एक मिनट। When compass is kept above the wire, it deflects in the left direction. ठीक है? Now what did we learn here and in the demonstration on the net? That magnetic compass always points in the direction of magnetic field. The magnetic compass always points in the direction of magnetic field. So that means below the wire the magnetic field direction is towards right, and above the wire the magnetic field direction is towards left. This is possible. Okay, so this wire is shown like this, but actually when you keep it on the table, it's like this. So if the magnetic compass is below, so it is deflecting in the right side, right? And when it is kept above, it is deflecting in this side. This is how it is going. That means the magnetic compass, magnetic field line is circular. Okay, then it is possible. A circle always directs like this. Understood? So it will become more clear with the other demonstration. So right now we have understood this. When the magnetic compass is kept below, then it points in the right direction. And when it is kept above, it points in the left direction. Clear? So this is our state. So why? And when will magnetic compass deflect? Whenever there is a magnetic field near it, only then. or magnet near it. Otherwise, it will always point in the Earth's magnetic field. Earth's magnetic field is very weak as compared to any bar magnet's magnetic field. Near the bar magnet, its field will be stronger. So, magnetic compass will be influenced by the bar magnet over Earth's magnetic field. Is that clear? Okay. So, this proves that any current carrying wire has a magnetic field around it. Otherwise, this would not have deflected. When we remove the key, then it does not show any deflection. When we plug the key, then it shows deflection. So this proves that every current carrying wire generates magnetic field. Is that clear? Any current carrying wire generates magnetic field. Okay, so this was Oersted's experiment. Anybody has any doubt? Read the experiment given in the volume and see if you have any queries left. So we covered magnetic field lines, magnetic properties, how to draw magnetic field lines, and Oersted's experiment. So far we have covered this one. So read all this. If there is any point you not understood, please ask. Also, हाँ, तो जिधर नॉर्थ पोल का कंपास पॉइंट करता है वही उसका डायरेक्शन मैग्नेटिक फील्ड. ये देखो ना, अभी यहाँ पे ऐसे था ना, जब इसमें करंट नहीं जा रहा था तो ये नॉर्थ, अर्थ का जो नॉर्थ है उधर पॉइंट कर रहा था, मतलब अर्थ की मैग्नेटिक फील्ड में पॉइंट कर रहा है. ठीक है, लेकिन जैसे हमने इसको प्लग क्लोज किया उसमें से करंट आ गया. करंट आ गया तो कंपास किधर गया? ये साइड, मतलब मैग्नेटिक फील्ड इधर है, वायर के नीचे. मैग्नेटिक फील्ड का डायरेक्शन क्या है? राइट. और जब कंपास को हमने ऊपर रखा तो ये ऐसे पॉइंट करता है. Above it points like this. यानी मैग्नेटिक फील्ड का डायरेक्शन वायर के नीचे और ऊपर. ये पॉइंट में इधर जा रहा है और ये पॉइंट में इधर आ रहा है, ऐसे है. ठीक है, अभी नेक्स्ट एक्सपेरिमेंट से और क्लियर हो जाएगा. Everybody understood? Read the properties of magnetic field line, very important.
Magnetic field.
वॉल्यूम किधर है तेरा? पढ़ उसमें. कहाँ पे? जाओ उधर. पॉइंट पर. Go there and point.
सर ये क्या है?
I current. Current का symbol है. Be specific in pointing out. सब प्रॉपर्टी समझ में आ गया? So relative, second point, relative strength of the magnet decreases as the distance from it increases. The magnetic field lines are closer where the field strength is more and our space where the strength is less. Understood? Where the lines are crowded, near the poles. But as you go away, what is happening? Are they spreading out? Look here. The space between the line is increasing now. So here the magnetic field lines, magnetic field strength is less. How to verify? When you keep the compass here, उसमें deflection कम हो जाए. ठीक है? The deflection in the compass will be less in the weaker magnetic field, meaning it will be more towards Earth's north. Earth north से जितना ज़्यादा deflect हो रहा है, मतलब वहाँ पे magnetic field उतना strong है. Is that clear?
Yes.
You need to buy बाकी है. तब कंप्लीट होगा। हाँ ये स्पेस और ठीक है। और देखो सबसे ज्यादा क्राउड कहाँ पे? पोल के पास में। सो मैक्सिमम मैग्नेटिक स्ट्रेंथ इज नियर द पोल्स। ठीक है, क्लियर हो गया? हाँ इक्वल है, डायरेक्शन उल्टा है। So any questions? Then it will be in the net effect of all the magnetic fields resultant. It may or it may not. So don't get into all that. First clear this. That is the application later on. Okay. Is this clear? What is mentioned here? Okay. It does not intersect. Why it does not intersect?
Because it cannot have two directions.
It cannot have two directions because intersection where two directions are possible. Where is the direction of the magnetic field? At any point?
From north to south outside the magnet.
No, that's not exact answer. At any point on the magnetic field line, what is the direction? It is along the tangent at that point. Okay, it is along the tangent at that point while going from north to south outside the magnet. Is that clear? These questions are asked. Why two magnetic field line cannot intersect? You should be able to answer it. Bata Daksh, why it cannot intersect? See, अभी बताया फिर भी आप ढूंढ रहे हैं. तू बता.
Because they cannot have the same direction, two direction at a given point.
Yes, at one point they cannot have. ये चौड़ा हो गया देख. Explain कर. Two directions क्यों होते हैं? क्यों होते हैं दो डायरेक्शन? एक जब इंटरसेक्ट कर रहा है मैग्नेटिक फील्ड लाइन ऐसा तो दो डायरेक्शन कैसे होंगे? बता.
Sir, the magnetic lines are curved outside the paramagnetic barrier.
अरे keep it set. दो टेंजेंट बनेंगे, दो कर्व है ना. हर कर्व पे एक पॉइंट पे एक ही टेंजेंट होगा. तो दो कर्व है वहाँ पे. दो टेंजेंट पॉसिबल है ना. Two directions are in the direction of the two tangents at the point of intersection. Keep it simple. Tangent क्या होता है? कौन बताएगा? What is tangent? What is tangent? Anybody? What is tangent? Sine by cos is tangent.
Sine by cos. The sine by cos.
Tangent क्या होता है? That is in trigonometry. Circle में tangent क्या होता है? What is tangent in a circle? Draw perpendicular to what?
The point on the circumference.
How to, let's say I have a point. How do I know this is perpendicular? Which line is perpendicular?
The line you will draw.
So I draw this. Is this tangent? Perpendicular to what? To the radius. Tangent is a line perpendicular to the radius. And it's only one line possible at any point on the circle. So if you have this point, you'll first draw the radius and then draw the perpendicular line. This is how it is. Now tangents have two directions possible. Which direction to take in case of magnetic field? North to south. While traversing from north to south, that direction you have to take of the tangent. Is that clear? So tangent बनाने के लिए, if you have any curve, let us say you have any curve like this, magnetic field curve हो गया. So ये point पे, so you have to imagine there is a circle over here. So every point the curvature is changing, isn't it? On a magnetic field, it's not a perfect circle. So to draw a perfect circle over there, Then only you can draw a tangent. But anyway, these are advanced concept. So tangent is basically a perpendicular drawn to the radius at that point. That is tangent. Is that clear?
Yes.
So दो tangent हो जाएंगे intersection वाले कर्व पे. अभी समझो एक कर्व ये है और एक कर्व ये है. ये वाला tangent हुआ इधर और ये tangent हो गया इधर. तो दो at the point of intersection there are two directions. ये नहीं चलेगा. Magnetic field because vector quantity has well defined magnitude and direction at a point. Unique होगा. Cannot have two values. Is that clear? So next is बस तो ये बेसिक्स था. ये सारा बेसिक्स जो हमने सीखा है वो आगे आने वाले हर टॉपिक में यूज होने वाला. ठीक है कि मैग्नेटिक कंपास कैसे रिएक्ट करता है मैग्नेटिक फील्ड में. इट इज ऑलवेज अलोंग द मैग्नेटिक फील्ड लाइन. ठीक है ना ऑफ द सोर्स. सोर्स मतलब वेदर इट इज मैग्नेटिक फील्ड ड्यू टू अर्थ और मैग्नेटिक फील्ड ड्यू टू एनी मैग्नेट और मैग्नेटिक फील्ड प्रोड्यूस ड्यू टू एनी करंट कैरिंग वायर. तो अब हम अलग अलग करंट कैरिंग वायर के कॉन्फ़िगरेशन लेंगे. एक बार स्ट्रेट वायर लेंगे, फिर एक बार लूप लेंगे, फिर एक बार सोलेनॉइड लेंगे. सब में से करंट जा रहा है और उन सब का कैसा मैग्नेटिक फील्ड बनता है वो सीखना है अपने. ठीक है ना. तो भी सबसे पहले जो हमको सीखना है वो क्या है मैग्नेटिक फील्ड लाइंस इन अ स्ट्रेट वायर, स्ट्रेट करंट कैरिंग वायर. मैग्नेटिक फील्ड लाइंस in a straight current going. Yeah. अभी हमने जो सर्किट डायग्राम बनाया था बोर्ड पे वो ऐसे था प्लेन पे. नाउ वी आर मेकिंग इट लाइक दिस. ओके मतलब ये टेबल है इसके अंदर हमने होल कर दिया और उसमें से वायर लेके आ रहा है. ठीक है. सो लेट अस से दिस इज आवर टेबल सरफेस एंड वी आर टेकिंग अ वायर फ्रॉम हियर नाउ लाइक दिस. Now how the current will flow? How will current flow now?
Again, now positive terminal to negative terminal.
Right. So this is the wire. From below it's coming out. So how will be the magnetic field lines now? How to draw the magnetic field lines? Either you spread the iron powder and gently tap it, or place the magnetic compass and follow its arrow direction.
But sir, magnetic compass will be too long process, right?
Huh?
Magnetic compass will be too long process.
No, it's not that long. You can very well finish it in 5 minutes. So what you see is this kind of magnetic field lines are formed and the direction is like this. Yeah, these are concentric circles.
They have the shape center with
Okay.
different radiuses.
Yeah, these are concentric circles. They are crowded near the wire. They are crowded. What does it signify?
The magnetic field is strongest near the wire.
Yes. So magnetic field is strong near the wire, and as you go away from the wire, it weakens. Plus, it is making concentric circles. Okay. It is making concentric circles in the plane perpendicular to the wire. Now come here. So now that you know what is the nature of magnetic field, around the current carrying wire, it forms concentric circles. Where is the center? Center is on the wire itself. Okay? So since the circle was like this, so that's why below the wire, the magnetic compass was pointing towards right. And above, देखो यहाँ पे भी direction उल्टा हो गया wire के दोनों साइड. On one side it is. So what is the observation? Just write the observation. It forms concentric circles. This is the observation. It forms concentric circles in the plane perpendicular to the wire. This is important. If you know this, then you can explain this. Why the compass is deflecting below the wire on the right side and above the wire on the right side. Perpendicular to the wire. Second observation is the circles or field lines are the concentric circles are crowded near the wire and spaced out away from. And the last thing is how the directions are given. It is given by right hand thumb rule. How the direction is given? Dekho, if the current is going like this, place the thumb in the direction of current and wrap your fingers around. So wherever the finger is turning, that is the direction of magnetic field. Okay. So the last point is the direction of magnetic field. Very important point. Direction of magnetic field. Yes. Is given by right hand thumb rule.
So who discovered this rule?
Right hand. It's not a discovery by one person, but we are told it is discovered by Oersted. Negative, positive, positive, negative. But if you're talking about electron, then positive stationary. So if electron positive is the but that is only solid conductor. Liquid में नहीं, liquid में दोनों ion, दोनों move. Okay, I'll see you in the next class. किसमें? Paranormal activity, कोई गलत नहीं.
इंग्लिश का तो नहीं 1 घंटे का नहीं पता 10 इंग्लिश होता है
एक घंटा बोलते हैं
मैं बुक
ऐसे
स्टार्ट
कर
कर
दूंगी।
डायरेक्ट नहीं जाता
ऐसे तो नहीं
नहीं
पूरा हिस्ट्री कर दी हमारे वो जो कि मैं एक्स्ट्रा कर दी
मैं ना बोल नहीं है मैं दोबारा जा रही हूँ कि मैं पेपर लिख
नहीं तू बोल रहा टाइम पे खा लेगा एक घंटा एक्स्ट्रा कर बोल